Neil does coloring in that. Arcs, sectors, segment, areas. This is the main focus. There's just a lot of yap being written as well. So it says the diagram shows a sector of a circle, center O. The radii, OA and OB, are each equal to R. And the angle at the center is theta. The line, DC, is perpendicular to OB. So let's just add this 90 degrees. Then it says, given that the ratio between BC, CO is 2 to 3, show that this shaded region is given by all of that. Okay, for 6 marks, you know. All right, let's make a plan. Okay, how are we going to make it? This plan, well, you can clearly see that we've got a segment here and then this random area. Okay, we'll figure out this area later. The segment area is super easy. So the segment area, how do you work out a segment area? You do the sector minus the triangle inside. Okay, so remember, segment is just sector minus triangle. Okay, so we have R, theta. So we have sector minus triangle. So we're doing this just to give you guys a little bit of a picturesque stuff. Now the sector of a circle is a half R squared theta. Then we're going to minus half AB sine C. Now with this, half AB sine C is your A's and B's are the exact same, right? They're both R. Half AB sine of the angle. So it's a half. When you multiply the R's together, you get R squared sine of the angle. Okay, so there's my segment area. That's not hard. The hardest bit of this question is working out this random area over here. So what do you think students are trying to do here? Maybe they'll try and split it vertically, do the triangle plus the trapezium. Maybe they'll even do 3 cuts here. They'll do triangle, triangle, rectangle. The way I see this is that I want to incorporate this right angled triangle as much as possible. Okay? If I can do this big triangle, which we've already done, we already know its area is a half R squared sine theta. If we do this minus this, we get this. So the main part of this question, guys, is don't focus too much on that shaded area and splitting that up into things don't split it up into shapes that will help you work out this. Specifically, think about the overall shapes, the bigger shapes that could subtract. So this weird area, I'll try and draw it out for you guys, which looks like this, is just going to be my big triangle minus the smaller one. Now both of them are obviously theta. Okay? So the big triangle here is, alright, so that's a half R squared sine theta. Minus, we need to figure out that one. But what do we know about this triangle? At the moment, nothing. But we have got this ratio. The ratio of BC is 2 parts to 3 parts. So this here, we can find that base length is 3 out of 5. Yeah, the total parts is 5. 3/5 of R. So this here is 3/5 R. And with this, with these two, we need to work out that opposite length. Because this is a right angled triangle, we could just do half base times height. Yeah. And the way I've drawn this triangle is actually slightly incorrect. It should really be more of a diagonal. Like that. Just to show that it's not actually a right angled triangle, right? So we need to work out this length here. I'm going to call it X. How are we going to do that? That's tan. Tan of theta. Tan of theta is the opposite X over that 3/5 R. So it means X is 3/5 R tan theta. So now we can work out its area. It's a half times the base length of 3/5 R times the height of 3/5 R tan theta. Can you guys see that? Yeah, let's go. Okay. So overall, I guess we just have to clean that up. Half r squared sine theta minus 1 times 3 times 3 is 9 over 2 times 5 is 50. R times r squared. Then we get tan theta. Okay, I'm going to call this one AUX. That's the awkward area. And now we're just adding them together, right? So we're just going to do this plus this. So we have our total, half r squared theta minus half r squared sine theta plus half r squared sine theta minus 9 over 50 r squared tan theta. And what's beautiful about this, mate, is that these just cancel. We're left with this minus this. Now clearly they've done some factorizing over 50 r squared. They both have r squared, but I need to rewrite this so it has a common denominator, which would be 50. A half is 25 over 50. Then we have r squared theta. Then we have minus 9 over 50 r squared tan theta. I'm just going to call this A. And there we go. We can take out the over 50. Look at the numerators, 25 and 9. There's no common factors, so it's just going to be 1. Then we have r squared. What's left? We took out the over 50 and the r squared. We're left with 25 theta minus, we took out the 50 and the r squared. We get 9 tan theta centimeters squared. And that is shown. Guys, if you liked today's video and you learned something, I'd really appreciate if you hit the like button, subscribe for more maths content. If you want to join the Lung Gang Reddit to submit your own questions, link is in the description. And if you're interested in my A-level maths courses, description has a link for more information. Nice.